All right, so here is our last one. We're putting it all together. And let's go ahead and just get started on the first one. So I'm going to notice that my intersection point is on the inside. And if I just scroll up to the top, just remember, all right, that what I'm doing is I'm taking the individual chords, all right, multiplying them together and setting them equal to the other secant, all right? So what that means is I'm going to take, if I first look at this secant, I'm going to take 9 times x equals, and then if I take a look at the other secant, I'm going to do 3 times 6. All right, I'm going to do 9x is equal to 18. And really quickly, I'm going to get x is equal to 2. Nice and easy, okay? All right, next example. This is one of the ones where I have a secant on the outside. All right, so I'm going to take the exterior, multiply it times the entire thing. All right, so in this first example, I'm going to do 3 times the entire segment, all right, which is x plus 3. So 3 times x plus 3 equals, and now I'm going to do 4, which is my exterior, times my total, which is 11. So I'm going to do 4 times 11, and then I'm going to distribute through. So I'm going to get 3x plus 9 equals 44. I'm going to subtract out that 44, all right, and I'm going to get 3x is equal to 35. And then I'm going to divide out that 3, and I'm just going to leave it as a fraction. So I'm going to have 35 over 3 as my final answer. Okay, next example. All right, what we're going to do here is we're going to do our exterior times our entire segment. So I'm going to do 9 times 13 equals this tangent squared. All right, so I'm going to do x squared. So multiplying the 9 and the 13 together, all right, so multiplying 9 and 13 together, 9 times 13 is 117. So I'm going to get x squared is equal to 117, and then I'm going to square root it. So if you want to at this point, you can leave it, all right, as a radical. You'd have to simplify it, all right, which would simplify into 3 times the square root of 13. Or since we've been kind of using things in decimals throughout this lesson, if you wanted to instead change it into a decimal, you could do that as well. Okay, I'm going to leave it as a radical when possible. Okay. Okay, next one, very similar. Okay, these are nice and easy, no quadratics so far. So what I'm going to do is I'm going to do 20 times the entire segment. So 20 times x plus 20 equals the tangent squared, so 31 squared. So simplifying, I'm going to do 20x plus 400 equals 31 squared, which is 961. I'm going to subtract out the 400, so 961 minus 400, which gives me 56.1, so 20x equals 561. And then dividing out that 20, you should get x is equal to 28.05. All right, last two might look a little bit harder. All right, so again, intersection points on the inside, so I'm just looking at the individual segments. So I'm going to do 3x times 2x. So 3x times 2x equals, and now I'm going to go ahead and do 18 times 3. So 18 times 3. So multiplying 3x times 2x, I'm actually going to get 6x squared is equal to 54. And I'm going to keep simplifying here. So I'm going to divide out the 6, and I'm going to get x squared is equal to 9. And then square rooting both sides, I get x is equal to 3. Okay, last one in my set, very similar to the last one. All right, I'm going to multiply the individual segments. So I'm going to do x plus 7 times x plus 2 equals x times x plus 10. So I'm now going to FOIL that first part. So I'm going to have x squared plus 2x plus 7x plus 14 equals, and now I'm going to distribute the x through, which is x squared plus 10x. I'm going to simplify the left-hand side, so x squared plus 9x plus 14 is equal to x squared plus 10x. And the good news is, guys, that the x squares cancel out. So what I'm essentially solving is 9x plus 14 is equal to 10x. And then I'm going to subtract out the 9x, so I'm going to get 14 is equal to x. And that's your final answer. So the last 6 were quite easy, but remember to use that quadratic formula if you can't factor, okay? All right, that's it. We'll practice this tomorrow. Hopefully it made a little bit more sense. Otherwise,